So let's start with our first model, that is linear regression model. So what does this linear regression signify? This is basically you are given a simple set of observations, like for example, let's say you are given group of observations like these points, and in these points you want to fit a single line so that you can actually depict these whole observations in a single line. So this whole depiction can be done using a single line, y is equal to alpha plus beta x. So x is like a feature vector here, and y is a predictor, y is a predicted variable. So x, and like x can consist of various features. I am here just signifying x so as a single feature which has actually group of features. So say x1, x2 and xn, and y is a dependent variable here. Alpha and beta are the intercept and corresponding slopes of features that by how much scale they affect the dependent variable. Like overall expression would be y is equals to alpha plus beta x1 beta 1 x1 plus beta 2 x2 plus dot dot dot. So this line will be actually representing this whole bunch of data. So here's a sample problem. Say you are given a number of friends x, predict how many goods I will receive on each Facebook post. So you are given a data set which is like, here it is fbgood.txt. so it's consists of two columns. One is friends, and another is get goods. So what I am doing here is like, let's look this code line by line. First I am storing this data set fbgood.text in a dataset variable by using the command read.csv. Read.csv, as you must have all gone through the basic R learning, this is a command to import CSV or any data frame file. Here head equal to true means like I have in the data frame we have a header like this. There's a header like there's a column name get goods and there's a column name friends. So there's a header and it will neglect the header and import all the data apart from this header. Separator is tab row dot namesys 1 means it starts from importing row 1. So after importing I'll store x and y with values friends and get goods. Here $sign will indicate that data set $friend means it will import all the friends rows in x and all the get goods rows in y. And after that I have use a function called plot. Plot is a function to means simply see the visual relationship between x and y. And then I have used a command fit then I have used a command lm stand for linear model, and I have used a y imply x. Y imply x means that fit a linear model implying that y is a dependent variable and x is an independent variable. So fit a line through the observations between x and y. So it will store the result in fit, and in this fit there will be a vector of values x and y, and this this vector of x and y I will represent it through a line. Here I am using the function ab line which will be shown with the color red and line width 3. So let us look the result. Here the result is like, see, y-axis, this is the fbgood and this is the number of friends. So in this is the plot, total scatter plot, and through the lm function I am just creating a regression line here which is like fitting this. But as you can see, this is not actually depicting. There is so much error here between any 2 points. You can see there are so many errors. So what I'll do is I'll try to fit a second order fit. Second order means I'll try, here is y is equals to alpha plus beta x square. This code like poly fit to lmy poly x square. Poly is a function to denote any polynomial expression. So I have created simply here x square, where y is the dependent variable and x square is an independent variable, and I am storing this result in polyfit2, and simply I am using the lines function and fitting a second order curve, sorry, with color equal to true 2 and line width is equal to 3. So here, like you can see, this is a more like good fit as compared to the previous one. And there were so many errors. This was not depicting accurately, and this is depicting much more accurately. So what will happen if I increase the polynomial degree? Like if I say increase the cube, x cube, let's say. So same concept, same syntax. Let's see the result. See, this result is like much more accurate than the previous one, because it's depicting these portion which is not depicted by the second order polynomial here, and the third order polynomial is depicting much more efficiently. But let me give you a caution that increasing the polynomial and fitting your data might not always be correct in some ways. Like you are given this data, this is like a training data for you, so you can see the result like it's giving a good fit, but this will not be a good fit if you are provided more data. So you will fit for it accordingly, so it will not give accurate result for test data. Like I'll now introduce to the concept of underfitting and overfitting. Like here you can see in this simply the data is scattered all over, so simply a line will not accurately represent whole of the data. But in the second plot, if we just increase the polynomial degree to some extent, we can say that yeah, it's representing somewhat approximately the data. But if we increase much more degree of the polynomial, like here where every point is meeting with the curve, we for this time we can say that yeah, it's predicting accurately. But if we are given a test data set, it will not predict accurately, because this curve is according to this data set. That's why it will not predict accurately. So there's a fine margin between an underfit, overfit and just right. So try to make your polynomial just right, not overfit, because it will introduce noise also. So that's it. And one more thing, I have just shown a simple syntax which is like how to use lm function which is in the stats package. Here you can see a simple syntax of lm. Like there's a formula, dv implies iv, where this is the dependent variable and this is a set of independent variables which will say as features, and this is a data provided. And like if you want if you have the model trained, and now you can use this model, like m is the model, you can use m, and you have the test data and you can predict using this model. This is the example. And so this is a simple general introduction to linear regression model. Next we are gonna see classification which is KNN, and which is quite interesting. Let's see next.